Hello, my name is Paul and I'm going to give you a lightning fast intro to coding. We're going to be using SpriteKit, which is a high-performance graphic system Apple introduced with iOS 7. This video is aimed at students with little or no knowledge of coding and uses a special helper library I produced for learners called EasyOC. If you are an experienced Objective-C developer, or if you're familiar with terms such as pointer, this tutorial is not for you. EasyOC uses several rewrites, hacks, and renames to try to make Objective-C easier for learners. The nice thing about it is that it lets you focus on what matters, getting results, getting things happening on the screen, while skipping over concepts that require a lot of upfront explanation. And of course, the users end up with a project that runs natively on the iPad at blazing speed. Before you start, please ensure you have Xcode 5 installed from the Mac App Store. You should also have downloaded the project files from stealmycode.com/EasyOC. When you extract the zip file, you will see this layout: easygame.xcode proj and an easygame folder. You can ignore this folder and just double click on the Xcode proj. This will fire up Xcode and launch you into the main files you'll be working with. In this case, it's called gamescene.m. You can see on the left here, gamescene.h and gamescene.m, and we're in the M file already. We'll be doing nearly all our work in this one file, occasionally going to the .h. To begin with, I just want you to press this play button. You can get that also with Command R on your keyboard, but just play for now. It will build the game, fire up the iOS simulator, and show you the amazing game so far. As you can see, it's a large blackish screen, nothing going on. The bottom right corner has 0 nodes and 60.0 FPS frames per second, and that's our game so far. Not very interesting. That's the most basic SpriteKit container. We're going to start building on that straight away because included in this project are a load of assets to get you started up with. They're all in here, supporting files, content, and you can see lots of graphics at Retina, at 2x, and non-Retina, all ready for you to start using. Of course, you can replace them later. Let's start with getting that background looking better. So type on your keyboard -space escape, and that will fire up the code completion system. This is a brilliant way to do coding with very little typing because we're lazy. We don't want to do too much typing. We want to have Xcode do most of the work for us. So type with me setup and hit enter. That will fill in -void setup. Then add an open curly brace and a closed curly brace, like that. That's shift square bracket in my keyboard. That fills in the setup method. It will be called by the app for you when it's time to load your game. So right now, if we have a look at Alt-Tab, we can see the large grey screen. Let's do something better than that. Let's put a background picture in there already. There's one already in there for you, which means you can start using it. And you type square bracket self set background image. Again, use code completion, just press enter now. And then quote background, quote end square bracket and semicolon. And that will set the background image to a file called background. If you want to learn the kind of way if you're slower, please start pausing and playing the video. I'm going to just crack on and show you the results straight away, but rewind all you need to. So self set background image background, press play now or Command R, and you'll see there's a nice sort of blue metallic background now. You'll see our FPS has dropped to 44-ish, 42-ish frames a second. Don't worry about that your Mac, even though it's a very, very fast computer, does not emulate iPad OpenGL graphics very quickly. That's okay. It'll be much faster on the actual final iPad. So with that one line of code, set background image background, we're now drawing this nice blue metallic background. You can see here void. That just means this method returns nothing of interest. Don't worry about it. And self refers to the current game scene. This whole area here is your game scene. You can draw into it and have your whole game happening there. Self just means for this game scene, set our background image to be the graphic called background, which you can replace later to be whatever you like. That's the most basic way to get started. Let's go up a notch. Let's look for ways to respond when the user taps the screen. So go beneath setup and again type -space escape and start typing with me SCR, and it fills in for you void screen touch : point location. Hit enter to fill that in. Enter again to do an open brace and a closed brace. Make that a real method. And we're going to write some code. Now for now, just follow along with the code. I'm going to explain what it does in just a minute. The code we want to do right now is create things on the screen where the user is tapped. And to do that, we're going to create a new box. Just to say, we've tapped the screen, here's a box. So to do that, I want you to write image space box equals square brackets make box with color. Again, it code completes, so just type box and press enter. It'll ask you what color do you want. Well, we can write square bracket colors random. And at size, just press tab to jump to that bit, press tab to jump to the size parameter. You can write make size with width. Again, it'll code complete. Width 64, height 64. And it's telling you these little ghost square brackets here mean you need 2 square brackets to finish off that statement. And then semicolon. So that will create a box of a random color at a size 64 by 64 sized, ready to go on the screen. We now position it, so box.position equals location. That's been passed in here. And finally, we call self add box, like that. So let's have a look at what that function is doing. We see here screen touch. When the screen has been touched, call this method, sorry. It'll pass in a point, which is an XY coordinate, and that point will be called location. That's its variable name, location. It then declares a new type of image called box, we can refer to it in our code, which is called by make box with color, a random color, at size, a size 64 wide, high. Then it places the position of the box to be location, the thing that was passed in where the user tapped, and then adds it to self, the game scene. So it adds the box to be self. So now press play and tap the screen. You see we have random colored boxes appearing on the screen. You will also see in the bottom right corner here the node count going up and up, 16 now, 17, 18, 19, 20, and so on. It's creating more and more graphics, and you can create them as fast as you like, many as you want, lots and lots of boxes being created. Awesome. So that is an image type of object. It creates boxes like that and graphics, and we're using that several times throughout this game. And a point, like I said, is an XY coordinate. And so far, it's a pretty dull game, let's face it. But we're adding the box we've created to the scene to be drawn. Let's make that slightly more interesting. Underneath self add box, I want you to write square brackets box add rectangle physics square bracket semicolon. So before we were saying self, send this message add, or this message set background image to self, to the game scene, do this thing. Now we're saying the message is to box. Dear box, please add rectangle physics to yourself. So it will affect the box rather than the game scene. Now press play or press Command R and click the screen. You'll see these boxes appear, then drop down, getting faster and faster because they have physics applied to them. They're dropping with gravity, accelerating over time, like that. We're getting there slowly, but as you can see, the boxes are falling off the screen, which is pretty tedious. Let's make that slightly smarter by going to setup method here, underneath self set background image, make a new line and type square bracket self create physics from edges, square bracket semicolon. And we press play. Now when you create a box, it will fall and bounce off the bottom. And you can create little stacks of these boxes now that respond quite neatly. So we've now got semi-realistic physics happening. Yeah, look at that lovely tower. Fantastic. What's happened here is that one line, self create physics from edges, has got an invisible line around our game window now, keeping those boxes inside, so they simply can't escape. No matter what you do, they'll just line up and pile up higher and higher and higher, never getting out, which is what you expect. There we go. So we now have boxes appearing on the screen very nicely and falling down and hitting the edges. Let's take it up a notch, because boxes are pretty boring. In the screen touched method here, let's make it do graphics instead. So where we have image box, replace that with image circle. And you'll see immediately I've changed box to be circle, and Xcode's telling me error, 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 because box stop position doesn't exist, add box doesn't work, and box add rectangle physics doesn't work, because it doesn't know what box is anymore. We've renamed it to be circle. So whenever you see box, type in circle, and self add circle, and circle add rectangle physics. So that'll do exactly the same thing. We'll just change the variable name at this point. But if we change this line here, make box with color, blah, 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 take all that out and change to be square bracket, make image, quote, ball red, quote, square bracket semicolon, that will load a graphic called ball red. This is one I made for you already. You can see it in here if you choose to see it. Ball red is here. It's a little red ball, like that. And it will load it into there and add it to the screen and add rectangle physics for you. But as you can see, it's a ball. Rectangle physics is the wrong kind of thing for a ball. We want to change add rectangle physics to be add circle physics, like that. When you press play now or Command R, you will see these balls pop up. And they respond like balls. They roll around beautifully like a ball and hit the edges, roll around and interact very, very nicely. They bounce fairly well. There we go, a bit of a bounce. We can adjust that by going to the line after add circle physics and saying circle.bounciness equals, well, it's a percentage. So let's do 100% bounciness. When you press play now, that ball's going to bounce properly. You've got bouncy balls going on now. And it'll bounce for quite a long time, nice bit of momentum in there, and as other balls come into the system, it will just bounce crazier and crazier and crazier. Very nice bouncy balls. So let's add something to make those balls bounce off rather than just having this invisible edge all the time. I'm going to take bounciness down to about 40%, which is a nice sort of bouncy level. And in setup, I'm going to add a little bouncer, so the balls will hit and bounce off. So it's an image I've made for you called bouncer. Here it is, there's the bouncer graphic. And to load an image, as you've seen, we type image, that's our type, and we're going to call this thing bouncer equals square bracket make image bouncer. That will load the graphic and prepare it to draw onto the screen. Now for now, we're going to add this thing to the center of the screen horizontally. So in the simulator about here, in this line. And at the very bottom of the screen down here. So half on, half off the simulator. So you only see the top half of the circle. Now in SpriteKit, all coordinates are centered to the object you're adding, which means if you say this screen is 1024 wide, which it is, if you add it 512, halfway of 1024, it will be exactly halfway in the middle of the screen. And 0, obviously this bottom point here is 0. If we add to y0, it means that the bouncer picture will be centered in this point here, 512x y0. So let's do bouncer.position is make point with x 512 y0. So centered horizontally and half off the screen vertically. It's a circle, so we want to say bouncer add circle physics and then add it to self. So we say self add bouncer. And when you press play, you will see something quite interesting. Well, I had said to you it'll be centered horizontally, which it has been, it's right in the middle. But vertically, it's actually halfway, well, it's fully onto the screen. It should have been, this point here, should have been all the way down here, with the bottom half of the circle completely missing. That hasn't happened, and hasn't happened for a very important reason, which you'll see when I start dropping balls. Do you notice I can move the bouncer? That's because we said add circle physics, so it's responding to physics. And as soon as we can make it do physics responses, it will hit those invisible edges we added earlier with create physics from edges. So it's hitting those edges and therefore being pushed onto the screen. So even though we said y0, we're actually getting a much higher y. So we can fix that by saying after add circle physics, we can say bouncer dot fixed in position equals true. And now nothing will move it. No physics will have any effect. The edges, those visible ones, will not push it up, and the balls will not make it move. They'll hit it, they'll bounce off it correctly, but they won't make it move. As you'll see if I press play, there it is correctly at y0, that's the very bottom of the screen, at x512 in the middle. And when I launch balls, have as many as I want, that bouncer ain't going anywhere, because it's fixed in position. So let's add more bouncers, more things to bounce off. And you might think, well, the best way to do that is to take all this code and copy and paste it like this. Look at all these lovely repeats. That's bad. You can do it that way, but it's extremely lazy and it will cause problems in the long term. The better thing to do is to create a new method. So I'm going to undo all that, make a new method, which means taking that code and moving it into a custom method. Now, so far, setup and screen touched have both been code completed for us by Xcode. Minus escape and start typing and it fills in the rest for you. This is a new method, one that Xcode does not recognize, so it will not code complete for you. So, go down after screen touched and type minus brackets void make bouncer at X. Now here's where you see some of the syntax horror that lies behind Objective-C, because it really likes to use colons, brackets, parentheses, square brackets, curly braces, all that kind of thing. It uses all sorts of these punctuation marks, and it can be rather hard to read at first. Again, we're just going to type it for now and explain it shortly. So make bouncer X, colon, bracket, float, X, space, Y, colon, float, Y. Then open brace, close brace, and paste your code in there that you had from setup. So these 5 lines here from setup are now in make bouncer at X, Y. You'll notice the code pasted in does have make point with X, X, Y, 0. So we want to replace this one with X and Y. That will use, rather than 512 and 0, replace it with the things passed in from the caller of make bouncer at X. We can now call that method in setup. We can say here self make bouncer at X 512 0 square bracket semicolon, and that will be exactly what we had before. It's the same thing, 512 0 being created, except now it's using a method. So really, at this point, it's no better. It's a bit cleaner perhaps, but it really is, it's no better. But the advantage is we can now create multiple bouncers without having to duplicate all the code. We can just take that line and paste it in 5 times, that, and add different numbers here. So we could say 0, 256, 512, 768, and 1024. So spacing them evenly every 256 points across the screen, that's power of 2 if you love geeky stuff, every 256 points across the screen we make a bouncer. And that's what that code will do. Now, temporarily going back to this method we just made here, this thing. I know it's a vomit of line noise looking characters, but it's a great way of showing how Objective-C works. So the first bit, void, this thing returns nothing we care about. It's going to make stuff in the screen, yes, but it returns no value. The method itself is called make bouncer at X, and it takes a parameter called X, so at X, X value, and a second parameter called Y internally. So this is what people outside it see, make bouncer at X, Y. Inside the method we use X and Y, which is perfectly fine. And these 2 numbers are passed in as what are called floats, which is a data type meaning a floating point number, which is a number like 3.1, 3.141, 3.141592654, whatever you like, any decimal number with things after the decimal place is a float. Now, when we run this code back, it will look like this. As you can see, as promised, we have bouncers at 0, 256, 512, 768, and 1024x. Remember, centering on the sprite itself. And they're all at Y0. So it's starting to come together. There are multiple things your ball can now bounce off, which is good. There we go. Magic. And we're starting to have some sort of game here, but really what needs to happen is between these bouncers need to be slots that you want to land into to get points. To do that, we're going to make a new method. Remember, methods are good. We hate code duplication. This is much, much cleaner than having that same code 5 times. Having 25 lines total will be a nightmare. So we're going to make a new method that's very similar to make bouncer at X, Y. It's going to be called make slot at X, Y, with an extra addition here. So these slots should be where the ball lands in order to get points here, in the gaps between bouncers. And there are going to be 2 types of slot. Good slots will color green, and bad slots will color red. So we want a method to create them as with bouncers. So back to your code, and after make bouncer x, y, make a new method called, so minus void, make slot at x, float x, and y, float y. However, like I told you, there are good slots and bad slots. So we could either make two methods, one for good slots and one for bad slots, make good slot at x, y, and make bad slot at x, y. Or we could add a third parameter here, which is it a good slot or not? So is good, colon, bool is good. A bool is a true or false value. A 1 or a 0 in computer parlance, on or off, is it there or not? So good or not good. Add a brace and close the brace nicely. So this kind of thing is very similar to the bouncer, and there are graphics for you already. So just type image slot base equals make image slot base good, like that. That will create the slot base graphic from a file called slot base good, which is here. It's a greenish rectangle. We want to position it at the position passed in here, x, y. So we say slot base dot position equals make point with x, x, y. Just like this line here for the bouncer. Nothing's new. And then we say self add slot base. So that adds a slot base to the screen. Now, as before, we need to call that method. Up here, you can see it making the bouncers. We want to call that method here before we make the bouncers. So, before those calls in setup, please add these lines. Self make slot at x, and we're going to add x128, y0 is good, true. So the first one's a good slot. 1 to 8, by the way, is halfway between 0 and 256. We want 4 of these lines, so let's copy and paste it 4 times. Now halfway between 256 and 512 is 384, so x384. Halfway between 512 and 768 is 640, so 640. And for the last one, halfway between 768 and 1024 is 896, so 896. Right now they're all good, but let's make that is good false for the second one and is good false for the fourth one. So it really mixes it up a little bit. So each of these slots fits nicely on the screen with the bouncers in between, separating them. And press play and have a look, and you'll see, great, look down here at the bottom of my screen, bouncer slot, bouncer slot, bouncer slot, bouncer slot, bouncer, but they're all green bouncers. Why are they all green bouncers? Look at the code. Is good true, is good false, is good true, is good false. There are 2 bad ones here. Why are they all green? Why are they all good? Simple answer, hopefully you're screaming at your screen saying the answer, is because my code make slot at x, y is good. Just says make image slot base good. It doesn't say if it's good or not, make bad or good. It does the same thing every time. We've written no code for bad slots. Now you might think the solution, if you've seen much coding or any coding before, is something like this. If is good, then make a good one. Otherwise, make a bad one. That. You might think that was a solution, and you wouldn't be far off, to be fair, particularly in other coding languages. But with Objective-C, it will complain. You can see there's 2 yellow arrows here, warnings here for slot base, and 2 red ones beneath it. And the reason it doesn't work is because these lines here and here are locked inside the opening and closing braces here. So this block, if is good, will run this code. If it's good, it'll do that. Else, it'll run this line of code. But down here, these 2 are outside this block, these braces here, and outside these braces. And so it doesn't understand what slot base is. You have to declare slot base to Objective-C before that if statement. You have to do it here. You have to say image slot base, like that. Just tell it. All you're doing really is saying, trust me on this, slot base is going to exist. That's what it means here. You're not saying what it is. Nothing actually happens here. It just says, listen, there's an image called slot base. Trust me. And then, if is good, you just write like that. Slot base equals make image. And that one there. you don't have to have the word image again here because that redefines it as a different variable. We just want to use whatever was declared here, put that in it if it's good, and that in it if it's bad. The same variable being used. So now those warnings go away. And we can now, hopefully, press play, and you will see a new game with green, red, green, red. So to recap, make slot at x, takes this extra parameter, is good, declares the image up front. Listen, there's going to be a slot base, trust me, is what you're saying to the compiler, the thing that builds the program. Then, if is good is true, if this is a good slot, then run all the code from that brace to this brace. In this case, it just says slot base equals make image slot base good. And if is good is not true, then run all the code from there to here. In this case, make slot base bad. So it's working correctly now. We have true, false, is good, meaning that we have good slots and bad slots. The nice thing about methods is to have this wonderful code reusability, which means we can make a change to that method now and have all those 4 function calls start using that change immediately. So we're going to make the slots look a bit nicer, and this is really just about taking the code for slot base and doubling it. So we have image slot base. Let's also add image slot glow, semicolon. Then if it's good, we want to say slot glow equals make image slot glow good, like that. And if it's bad, we have slot base and slot base bad. We need slot glow is make image slot glow bad. So the same code, just taking base and replacing it with glow. The same for its position. So we have slot base dot position equals make point xy. Let's do slot glow dot position equals make point with x, y. And finally, add the base. Let's do self add slot glow. So that adds the glow to the screen as well as the base. Press play, have a look how it looks. There we go. There's the base, there's the glow. Looks very nice, not complicated I feel. But we can make it look even nicer. We can make that glow, this graphic here, these red and green glows, spin around all the time to make it really clear to users this is a good thing, you want to land in there. Because we're going to add an action to these slot glows. Actions make it really easy to animate things. So at the end of make slot at x, y is good, here, where we'll just add the slot glow, make a new line and say action spin equals make rotation to, and just type ROT like I've done and press enter. It'll fill all the code in for you. Remember, coders are lazy. We don't want to write code if we can avoid it. Make rotation to 90, i.e. 90 degrees. Duration 10, i.e. 10 seconds. And repeat forever. Square bracket, semicolon. That will rotate from where it is right now to 90 degrees over a period of 10 seconds, so 9 degrees a second, and repeat again and again and again, making it always spin. If you press play now, you'll see nothing's actually changed. Nothing's moving, there's no spinning happening here. That code's done nothing. And the reason that code's done nothing is because we haven't told Xcode what to spin. So we need to say a message to the slot glow. That's what we want to spin. Hey slot glow, please run the action we made called spin. Like that. Slot glow run action colon spin. And when you press play now, you'll see all the glows spin very gently around and around and around forever. They will loop infinitely. So the game is starting to appear slowly as a thing. Maybe you're starting to recognize the kind of game we're making. If not, you've never been to Japan, that's for sure. Our goal is to make a ball drop on those slots. If you see right now, if I drop a ball, there it bounces down nicely. But if you look really closely, I'm going to zoom my screen in really closely. That ball is not on the slot. It's gone beneath the slot. It's resting next to the slot, overlaps the slot, as opposed to landing on the slot. And the reason for that is because those slots have no physics attached to them. They don't exist in our physical world. You can see them like our background, but they have no physical properties. So in your code, make slot at x. make sure you add rectangle physics somewhere in there so we know they're working. And we want to do it to the base, not to the glow. We want the glow to actually bounce off things, just that basic part there. So somewhere in here, let's do it here. We want to say slot base, add rectangle physics. So the ball will bounce off it correctly. We will also need to add something else, otherwise it will move when the ball hits it. Hopefully you realize we've done this before with the bouncers. It's fixed in position like here. So we say slot base dot fixed in position equals true. And that will make sure it responds to physics correctly, but will never actually move. Press play now, and you will see the ball bounces and drops correctly onto the thing like that. There we go, as opposed to landing next to it and overlapping it, which we don't want. So let's do something cool when collisions happen. SpriteKit loves to work with names. You always name things in SpriteKit, and by giving them a helpful name, it will let you distinguish between things later on. So let's name things. We're going to name 3 things. The good slots we'll call good, being helpful. The bad slots we'll call bad, and the balls we'll call ball. You could, of course, call these things Frank, Jim, and Elvis, but it will make your life extremely hard. And if you're working in a team, people will really, really hate you. So in make slot at X, look for is good, slot base, and slot glow. And after that, type in slot base dot name equals. We want to give this thing a new data type called a string. This is a sequence of characters. And to make a string, you just write square brackets, make string, and write your string. In quotes, we'll call it good. So our good bases are called good. And let's copy and paste that into the bad bits here. Slot base name equals make string bad. So when we load the bad base and the bad glow, name them bad. So good for the good ones and bad for the bad ones, as you might imagine. Then when we create the balls up in screen touched here, we create the balls here. We want to name these things ball. So let's use circle.name equals make string ball. Like that. So now we have names attached to our objects that matter. We can know which ones have collided, and we can make a method to handle collisions. So scroll down to the end. Underneath make slot at XY is good here. And let's create a new method. Now this one exists already, so it should be code completing for you. You can type minus space escape and look for COL, and you'll see collision between image thing 1 and image thing 2. Hit enter to fully complete the method for you. Then make a new brace and a close brace to get a really nice method. This will be called every time any 2 images collide. Thing 1 and thing 2. When they collide, it will trigger this straight away. The question is ball going to be passed in as thing 1 or passed in as thing 2? Please have a think for a moment. Pause the video, have a think, come back with your answer. Okay, you're back. I'm guaranteeing you probably haven't paused the video, but never mind. I'm going to crack on anyway. The truth is we don't know whether the ball is thing 1 or thing 2. The ball could be thing 1, the bouncer could be thing 2, bouncer could be thing 1, ball could be thing 2. And so we need this method here, collision between thing 1 and thing 2, to distinguish correctly between whether the ball is thing 1 or the ball is thing 2. And we can do that by just asking the name. What is your name? What do you equal? So we need to check both. We're going to write some code here. Let's do if bracket square bracket thing1 dot name equals ball. Now watch out here. We have if bracket or parenthesis if you're American, then square bracket or bracket if you're American. Thing1 dot name equals colon ball bracket bracket. So there's a lot of punctuation going on here like usual. Objective-C just loves punctuation. If thing 1 is the ball, then do something. After that we want else if thing 2 dot name equals ball. Like that. So if thing 1 is the ball, do stuff. Else if thing 2 is the ball, do stuff. So the question is, what should we put in there? Now, realistically, it's the same thing for both situations, whether it's here or here. Do something with the ball, do something with the slot, make something happen. Except that thing 1 and thing 2 are flipped around. So this is another great example of a need for methods. We don't want to type the same thing in there twice because it duplicates code, repeats yourself, and it makes it really hard to make changes in the future. So we're going to create a new method after that one. So type with me, this is a new method, it won't code complete for you. Minus brackets void, ball, colon, image ball, collided with, colon, brackets, image brackets, thing, open brace, close brace. That's our method. And what that means realistically is this ball collided with this other thing. So it takes this method, collision between one thing and another thing, distinguishes which one's a ball and which one's the other thing, and passes that result onto this method. So we can now call this with the right information. So if thing 1 is ball, we want to say self ball thing 1 collided with thing 2. We know thing 1 is the ball, therefore thing 2 is not the ball, or it's a different ball we care about, but it's something else. Else if thing 2 is the ball, then self ball thing 2 collided with thing 1. Thing 1's the other thing. This code will still not do anything, and that's because, of course, we haven't actually filled in this method here. So we figured out which one the ball is it thing 1 or thing 2. We've done nothing with that information. So now we want to try and take an action if we've collided with a good thing or a bad thing. So we've named our slot bases good and bad here. We can check the name here to figure out if it's a good result or a bad result. But for now, all we care about realistically is just saying the ball's hit the slot, get rid of it. So in ball collided with, add this. Again, watch out for the sneeze that is the syntax of Objective-C. If thing.name equals good, then let's remove the ball from its parent game. So we'll say brackets ball remove from parent. Else, if thing.name equals bad, we collide with the bad slot, then ball remove from parent. So same thing either way, basically. So regardless of whether it's a good slot or a bad slot, it's going to remove the ball from its parent from the game entirely. When you press play now, it will look like this. Beep, gone away. Green one gone away. Off a bouncer, does nothing, then goes away. So we've made the bouncers completely innocent, but all the slots, green and red, will automatically remove that ball from the game straight away. That is, of course, utterly tedious. Players want to score points. Players love these virtual points. They feel like they've achieved something playing your game. So we're going to try and show a score. And to show a score, we have to go inside this file, gamescene.h. All this time we've been inside gamescene.m here. We're now going to go to gamescene.h. And that's where you declare variables that need to be used more than once across your whole game. We need to declare 2 variables in gamescene.h. Go into the file, make some space between @interface and @end, and add these 2 lines of code. Object, label, score label, semicolon, value, int, score. So these are 2 new variables, and they're 2 very different things. Let's start with the second one, value, int, score. This is an integer. Integer is a whole number, like 0, 1, 2, or 2 million, or 2 billion. It's a whole number, no 2.1s or 2.4s, none of those. A whole number. And we're calling it score. This will hold the actual number attached to the user's current score while they're playing your game. And it's a value. It's a simple mathematical value. Nothing about RAM or complexities to be stored or held onto. It's just a simple number. Above here we have score label, which is a type label. And this is a visual thing that will be shown on the screen showing the score value, because this is just an internal number, no one can see the integer. A label actually shows that number on the screen. And it has information about it like position and font and size and color and that kind of thing. and it has to be an object. It's something that has to be stored in RAM very carefully. So that's object types and value types. Values are simple numbers, or bools, for example, are values. Most other things are objects. So this integer defaults to 0, which I want for a score. We want score to start at 0. But that just declares these things. To actually use them, we have to go back to gamescene.m. So forget the H again now, go back to the M. Look for the setup method and go to the end underneath make bouncer at X. And we're going to create that score label. We're going to put things inside the score label value we created a minute ago. And to do that, we say self.scoreLabel equals brackets make label with text. Hit enter to complete that thing. So text for now needs to be quite simple. Quote score colon 0 quote. So score 0 makes sense. And the font, there are lots of iOS fonts to choose from. A nice simple example one is called Chalk Duster. So CHALKDUSTER quote square bracket semicolon. So label with text score 0 font name Chalk Duster. And we want in this case to align it to the right of the screen because we're going to try and position this score label up here somewhere. And when you align to the right, it will go no further than the position you specify. This is important because if you imagine the score label starts here in the screen and goes to score 10 or score 1,000 or score 10,000 or score 10 million, if it's fixed on the left, it will overlap onto the right and just go off the screen. If you align to the right, it will never go further than the point you specify, so it will move to the left as the score gets higher and higher and higher, which is great. So to align that thing to the right, we just say self.scorelabel.alignment equals align right. We're going to position it, like I said, top right corner of the screen. In screen coordinates, this is 0, 0. This is 0, 768. This is 1024, 0 over in the bottom right. And this top right is 1024x 768y. So we're going to position this self.scorelabel.position equals make point with x. We're going to use x 980 on a 1024 screen right near the edge, and y 700 on a 768 high screen, so really quite high up. Then we have to say self add self.scorelabel. You'll have seen Objective-C loves to say self, 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 self. It's a very self-centered coding language, but that's okay. Press play. There's our score label, score 0. Of course, you can now play the game and nothing happens. A lot of this, the game's still quite boring. We have our variable called score, that's an int, value type int. We need to make a method that takes that int and puts it into our score label. So go down to the bottom of your code, underneath ball collided with, and add a new method. This one will not code complete for you. So minus brackets void, update score, open brace, close brace, there's your method. And this thing needs to make a new string saying score colon blank, no score yet, append our integer to it, and update the score label with the score. So new data type string, variable name we'll call new score, and to make a string we just say brackets make string score colon space, nothing at all, nothing, no text in there, no number in there yet, and end the string. We now want to append our score integer to that string. So we say dear new score, please append int self.score. Then we have our score string updated to say score colon 1 or score colon 2 or whatever you like. We now need to put that string into the score label. So we say self.scorelabel.text equals new score. There we go. That's all it takes to make a new string saying score 10, score 20, and put it into our label. It won't do anything just yet. So all we've done is made a method called update score. We have to make it adjust that score integer as things happen and call update score as needed. So we can see here in ball collided with, if the thing it collided with is called good, or if it's bad, in the good bit, I want you to write self.score equals self.score plus 1. That will add 1 to the current value of the score integer, the internal number, not the visible representation. To change the visible representation, we have to call our new update score method. So write brackets self update score. Update score, like that. And that will add 1 to the number here, then call update score, which will in turn create a new string, add the score integer to it, and display it on the screen. Now I should say at this point, very, very few coders write this kind of thing. Self.score equals self.score plus 1. Even Objective-C, the world's most self-centered language, coders don't write that. We normally write self.score plus plus, which just means the same thing. Add 1 to self.score. You may be aware, tangentially perhaps, there's a coding language called C, and there's one called C++. C++ is one higher than C. Oh, how the coders laugh at our hilarious jokes. That just adds 1 to the score, then calls update score. So now let's press play. And you'll see I can drop the ball, and it goes 1, 2, score's changing the entire time, 3, 4, 5. On the red one, nothing happens yet. So go back to your code, and underneath ball removed from parent, write self.score minus minus. That subtracts 1 from the current value of self.score. Then say self update score, and press play. So when it's a good ball, a good slot, it adds up. When it's a bad slot, it counts down, all the way down to negative numbers. Just by using ball collided with and distinguishing between the name good and bad, it adds and updates, or it subtracts and updates. So clearly right now this game is ridiculously easy to win because there's no problems just dropping balls from here and getting infinite points. Look how incredibly awesome I am at this game. It's so easy. Let's make this harder. Let's put things in the way that stop the ball dropping straight down. And this is where you may start to recognize this game is pachinko from Japan. Very, very famous ball game. Very, very loud ball game if you ever played it for real. We're making this in Objective-C. So go back to gamescene.h, because as with these two, we need to track variables across the game for this information. So first, we're going to add one called object label edit label. And that will just show the user whether they are in game editing mode or game playing mode. And again, it's a label, lots of information, lots of memory required to create that. It's an object, lots of data, complex information. We also need to track internally whether we are in editing mode or not. And that's simply a bool. And like an integer, it's a value type, a simple bit of a fact. Value, bool, editing mode. So it's a value type. It's a simple 1 or 0, yes or no, true or false. So we need to add a button to the screen that lets us determine what's editing mode and whether it's not editing mode. And to do that, go back to gamescene.m and go up to setup. And this code here to create a score label, we're pretty much going to repeat that, except this time we're going to put it on the top left side of the screen. And we don't have to bother aligning it. The default alignment's center, and its edit or done is about the same size, so there's no really worries about alignment. So underneath score label, please add self.editLabel equals make label with text. Again, please use code completion. It's so much fun and makes our life so much easier. Default text should be edit. And font name, go ahead and use chalk duster again. Good. Beneath that, let's position it top left corner of the screen. So this is X0, so we want about X80-ish, X100-ish, and Y about the same as score label. So let's do self.editLabel.position equals make point with X 80 Y 700. Top left corner of the screen. And again, add that to the screen. So self-add self.editLabel. Like that. You can now press play and see how it looks on the screen. There we go. Doesn't do anything, of course. You can tap on it and the balls basically fly down as if it just tapped there in the first place. We want to try and make that edit label do something more interesting, which means when the user taps the screen, figure out whether the edit label was tapped. And if it was, do something. If it wasn't, create a ball. So here comes a section that many people screw up. So watch very carefully or pause and rewind the video to your heart's content. We need to try and detect what the user clicked on. So look in the screen touched method here and add a line break before at the very beginning. And here's a new data type. We're going to use a data type called an array. And this is a collection of items. So we can ask the game, please tell me what objects in this game are at the point the user touched. And it could be 1, it could be 100, it could be 100,000. So it's an array. It'll pass back a full collection of all the objects. So this data type is cunningly called array. So we're going to say array objects equals self objects at point. We're going to ask the game, tell me all the objects that exist where the user tapped the screen, and we know the user tapped the screen here at this location point. So we can just write location in there. And it will return to us an array of all the objects that exist at that point. Now here's the place where people get it wrong. So watch carefully. We want to ask the game, does that array of objects where the user tapped contain the edit label? And to do that, you say if bracket bracket objects contains object colon self.edit label, like that. End the if statement here, and this is the careful bit. Write else open brace and indent all these lines underneath the else statement like that, all under there, and end the else. So all the code you had before in screen touched should go in the else block here of our if statement. So this code will only be executed if edit label was not tapped. If it was tapped, this space in between here, we can take some other action. And we're going to use a method we haven't written yet, so relax, I'm going to warn you, but we'll do it in a second. We're going to make a method called self edit toggle edit toggle T-O-G-G-L-E, there we go, toggle edit mode, and that will toggle edit mode to be either true or false. And look, it's warning us saying toggle edit mode, what's that? I don't know yet, because we haven't told it what toggle edit mode is. But that's okay. So that will toggle edit mode. We'll try to. It's going to call a method. We need to create that method now. So make some space beneath screen touched, right, minus brackets void toggle edit mode. I spelled it right first time. Open brace, close brace, and that warning goes away because that method now exists. It's not going to error anymore. It's empty, but at least it's valid code to call an empty method. So what should toggle edit mode do? Well, first it should change the edit mode value from true to false or false to true. And to do that quickly in code, you say self.editing mode equals exclamation mark self.editing mode. Remember, coders are lazy. We abuse all the keys in the keyboard for our own evil means. An exclamation mark means not. So this line in English would read, self.editing mode is not whatever self-editing mode was in the first place. So if this was true, it's not true, therefore it's now false. If it was false, it's not false, now it's true. So this flips the binary around, true, false, false, true, 1, 0, 0, 1. And now we should update the user interface. So rather than saying edit all the time, it says done when you're editing and done if you're edit if you're not doing editing. So to do that, we say if self.editing mode. So if we are currently in editing mode, we want to say self.editLabel.text equals make string done. So if we are editing, make our edit label read done. Else, we are not currently editing, self.editLabel.text equals make string edit. That. If you press play, you will see the edit button now works correctly. So edit done, edit done, edit done. But it doesn't do anything. You know, if you're in edit mode, it creates balls. If you're in not in edit mode, it still creates balls. But it kind of works. We're partway there. So now comes the real challenge of the game. We want to make it when the user taps the screen in editing mode, they create obstacles. So here's our screen touched method. Let's go over it again just quickly. First thing it does is it says, hello game scene, give me all the objects at the point, location, where the user touched the screen. Does that array contain the edit label? If it does, toggle editing mode. If it doesn't, create a ball. We're going to hijack this part of the code. So if we're in editing mode, it does one thing. If we're not, it creates a ball. So to do that, here we're going to nest a second if statement. So if object contains object, else if self.editing mode. Do stuff. Else everything you have so far, like this. And end the else. I should say at this point, if you like key shortcuts, you can save yourself so much time. When you have all the chunk of code, you can just select it all and press Command right brace to indent all you want to, and left brace to outdent all you want to. Much faster than doing it line by line. So now it reads, get everything we just tapped on the screen. Does that include the edit label? Yes. Toggle edit mode? No. Are we in editing mode? Do nothing. Else, create a circle. So you press that back now, play it back now, you'll see we're not in editing mode, we can create balls. We are now in editing mode, we can tap all you want to, does nothing at all. Off again, create balls. So the question is, what should go into here? And the answer is pretty much that same code we wrote at the beginning of this video. We're going to create boxes on the screen with physics. We're going to make it slightly different this time, slightly easier to read, because you can create very, very long lines of code, but please don't, because your colleagues, friends, family, your pet hamster will hate you for doing that. So please don't do that. We'll make nice short lines of code, starting with a size. What size should we create our boxes? Well, let's make a size data type, variable called sz, and use equals make size with width 16, height 16. Just a new data type like int or string or array or label size. Just holds a width and a height in one place. We're now going to create that random colored box we had in the beginning. So image box equals make box with color, colors random, at size sz, our size. Oops, our size we declared here. We're also going to rotate the box a random rotation to make it slightly harder for users. So it's all straight, it'll just bounce very predictably. When they're random rotations, it will bounce unpredictably and make it very, very hard to play, which is good. So we're going to say box.rotation equals make number between 0 degrees and 180 degrees. So any kind of angle happening here. We're then going to position the box where we tapped, which is of course this location point. We also need to add physics to this box so the balls can bounce off it correctly. So hopefully you know by now, you just type box, add rectangle physics, square brackets, semicolon. And we don't want these boxes to move because they're pins in the game. So we want to say box.fixed in position equals true. And finally, add those boxes to the game. So self add box like that. Now when you press play, you'll see the edit button does lots of things. Press edit, we're in editing mode now. I can tap and it creates these multicolored boxes across the screen. Add as many as you want. Lots of these things make the game nice and hard, well not too hard hopefully, and then come out of editing mode and drop a ball and you get this effect. Hey, green. So they get points based on how well they drop the balls through a fairly, rats, red, drop the balls through your pins. And that's our game finished. Congratulations, in less than 1 hour, you have made a game that loads boxes, loads pictures of balls, adds physics, rectangular and circular, catches user touches, adds bounce to things, gets points with labels, counts up and counts down, and has editing mode and more. It's a great foundation for a real game. I'm going to make a short second video that adds some suggestions for new things you can do, but for now, congratulations, you're done. Take a break.